In an aqueous solution, the ionization constants for carbonic acid are K1 equal to this and K2 equal to this. Select the correct statements for a saturated 0.034 molar solution of carbonic acid. First of all, what is carbonic acid? It is H2CO3. Now we are given two ionization constants. That means it will first of all ionize to H plus plus HCO3 minus, right? This is called the first ionization constant, which is K1 equal to 4.2 into 10 raised to the power of minus 7, right? Now we're given the second ionization constant. That means HCO3 minus will go into H plus plus CO3 2 minus, right? K2 will be equal to 4.8 into 10 raised to the power of minus 11, right? Now it is saying select the correct statement for the saturated solution. The concentration of CO3 minus, we have to calculate this. The concentration of CO3 minus is greater than that of HCO3 minus. The concentration of H plus and HCO3 minus are approximately equal. The concentration of H plus is double that of HCO3 minus, right? Now these are the two reactions. If we see over here that we can very well say that K1 is greater than K2. K2 is very negligible because it is, if we divide K2 by K1, it will be approximately what, 10 raised to the power minus 4 times, right? So that means K1 is very large as compared to K2, right? That means this dissociation, the dissociation of this equation will be very low as compared to the first equation, right? Now if I see over here, that means that whatever the concentration of H plus, if H plus total, if I talk about, it should be equal to what? H plus from the first equation plus H plus from the second equation, right? Now if K2 is very small, that means this dissociation will be very less. That means we can directly cancel this out. So we can directly write that H plus total will be equal to what? H plus from the first equation. That means, and from the first equation, whatever be the H plus we are getting, same will be the HCO3 minus. Is that right? Because both of them will dissociate to an equal extent, right? And this dissociation of HCO3 minus will be very less. That means these two will be nearly equal. That means option C is correct, right? Now we are talking about the concentration of CO3 minus. A option, it is saying the concentration of CO3 minus is 0.034 molar, but which is not possible because the dissociation of HCO3 minus is very less because of the constant, because of the ionization constant. So it cannot be 0.034 molar. That means option A is wrong. Now if we talk about B, the concentration of CO3 minus is greater than that of HCO3 minus. Now this is also wrong because HCO3 minus comes from the first equation, for which K1 is higher. That means its concentration of HCO3 minus definitely will be more than the concentration of CO3 minus, right? That means option B is also wrong. Now D, it is saying that the concentration of H plus is double that of CO3 minus, but we cannot say that it will be double or not, because H plus, we know that it will be very higher than CO3 minus, but it is very difficult to say that it will be twice. That means option D is also wrong. That means only option C is correct, right?